So let's plug it in, and that is cool, dude. Hey hackers, so before I begin the video, this is a new series called Let's Learn, and I'm kind of starting this off because we just hit 100 subscribers. I feel like this series could really bring up the channel and really be entertaining for you guys. So basically, Let's Learn is basically going to be a series where I learn different cybersecurity tools or cybersecurity software and just a bunch of other cool things where I'll actually learn how to use it properly and kind of teach you guys how to use it as well. So you kind of learn with me rather than it just being like a tutorial. Hope you guys kind of get that. So for the first episode, I thought the USB Rubber Ducky would be cool. I'm wearing the color yellow, or black and yellow, because it's the colors of the USB Rubber Ducky. So figured that would be awesome. So hopefully you guys enjoy the video. Make sure you leave a like, subscribe, do the whole thing, because we just hit 100 subscribers. Let's try to get to 1,000 subscribers. But anyways, enjoy the video. I'll see you guys later. Hey hackers, Blue Cosmo from CSCS here, and this is not your normal USB drive. This is the USB Rubber Ducky. The USB Rubber Ducky is basically a device that can inject keystrokes. It is a programmable keyboard, and meaning that you basically have control of your own keyboard that you can bring around with you, plug into other people's devices, and automate certain tasks. So we can, do document exfiltration, installing backdoors, some other type of remote access thing, even funny pranks by changing their wallpaper or something. But this device, you probably may have heard of it already if you watched the TV show Mr. Robot, or just have heard of the device from how notorious it is from the Hack 5 team, from Darren Kitchen and Shannon Morris and even Sebastian Kinney, I believe that's how you pronounce it. The rest of the Hack 5 team did an amazing job with this device. So let's learn how to use it. Alright guys, so this is Hack 5's very beautiful website where they display the USB Rubber Ducky. If you guys wanted to buy it for yourself, I'll have all the links and stuff, not in the description, but on the GitHub, because YouTube flagged my ethical hacking tools video for putting Hack 5 link in the description. I don't know why, but it's all on the USB Rubber Ducky Let's Learn. It's in my GitHub. You just go on Cosmodium, which is the link in the description, the Let's Learn, and the first one that pops up, which is the USB Rubber Ducky as of right now. And there's a bunch of links and resources that we go through the entire video, and some of the other files that you guys will be seeing throughout the video. So this is the actual GitHub page for the USB Rubber Ducky on Hack 5 Darren Kitchen, CEO or owner of Hack 5, and the GitHub should have all the basic stuff you should need for the USB Rubber Ducky if you need it. I keep looking over here. The camera's over here. Yeah, this is the website, so let's go ahead and buy it. Alright guys, so this is the type of thing you would expect to get in the USB Rubber Ducky kit. Here you can see we have the USB Rubber Ducky book or manual, and it basically is going to teach you how to use the USB Rubber Ducky effectively and how to use it, smartly, I guess. There's a little cool comic on the back, and it teaches you some of the syntax, the anatomy of the duck, and everything you're just going to need to know and how to use it. So this is probably going to be the first thing I'm going to go through officially. Also in the package you'll get this little card for the USB Rubber Ducky with the steps: write, encode, load, and deploy. So we'll have to remember those and go through those. Here is the actual USB Rubber Ducky. It is housed in this USB drive case. I don't really have nails. Let me try to open it. There you go. Whoops. But yeah, this is the USB Rubber Ducky. You can see that it has this little micro SD card slot. Bring it up here. I don't know how well you can see that. But yeah, it has a little micro SD card slot. So if you have a micro SD card like this, you can put it in here, and that's basically where all your payloads are going to be stored on. You'll store your payloads on the USB Rubber Ducky, you'll store your payloads on the micro SD card, encode them so that way they can be read by the USB Rubber Ducky, put them in the USB Rubber Ducky, and then you put this in a computer or in a device, and it will run the payload that you made. So that's pretty cool. Some other things I have is an adapter for USB-A to micro USB. So you can either plug in the USB Rubber Ducky into Android devices, or using the micro SD card to USB-A adapter, you can put the SD card on here, put this in here, and now you can edit the micro SD card on an Android device. Same thing with this USB-C adapter. You can probably edit on like your iPad or like a MacBook, and on with the USB Rubber Ducky, you can plug this into a MacBook or a iPad. So those are all the things that comes with this. Is just the packaging that houses the USB Rubber Ducky. So yeah, that's it. I guess we should go through the book, take some notes, and see where we go from there. Alright guys, so I finished the notes from the book right here. First of all, great book. I definitely suggest it if you guys have or own the USB Rubber Ducky. It gives you a lot of background information on how the USB Rubber Ducky works and how to use it effectively, and different things you could use it for. And it was just really good. So shout out to Hack5 for making that happen, making that work. But I finished the notes, and I figured to put it on GitHub because it was going to be hard for you guys to read. Plus, I know you guys probably want my notes. So there you go. USB Rubber Ducky notes. So I'll kind of go over the modules real quick. So in the first module, which was keystroke injection, it basically teaches you about how keystroke injection attacks work, right? It talks about how computers rely on inherent trust, and they just kind of like trust user input. Like if you're on Linux and you just like delete a file, it will delete the file like through the keyboard. There's no like, are you sure you want to delete it type of thing. And a lot of that comes from the inherent trust that computers have on the user, and the USB Rubber Ducky kind of manipulates that to its advantage. Module 2 just talks about the USB Rubber Ducky itself, what you can use it for and how it works. The third module was the anatomy of the duck. So it basically tells you the different parts of the USB Rubber Ducky. So first there's the payloads, which is basically the things you program and tell the USB Rubber Ducky what to do. So if you were changing someone's wallpaper or making opening their notepad and typing in hello world, that's what the payload is. It's what you're programming the USB Rubber Ducky to do. Ducky script is just the language that you use to program the Ducky, and we'll cover this in the next part. In order for the USB Rubber Ducky to actually read the payload, it needs to be encoded so that way it can actually be processed by the computer or the CPU. The inject.bin file is just the encoded version of the payload. Then it just talks about some of the hardware components like the SD card reader. Module 4, which is the attack workflow, basically teaches you how to effectively use the Rubber Ducky to attack a target or do something for a client you may have, right? So it talks about pre-engagement interactions, which is basically kind of getting information. It's basically like pre-reconnaissance, I guess, right? I guess these two are basically the same thing, reconnaissance and pre-engagement interactions, but they're not exactly the same thing either. So it's just supposed to save you some time, understand what hardware, software, networks you'll be working with. Similar to reconnaissance, it's getting a better understanding of the systems that you may have or challenges you may face. The target is basically your target, right? Or your client or whatever you're using your Rubber Ducky against, right? Research is very important. So when you're testing the Ducky script, let's say if you wanted to, I don't know, open the terminal and type in ifconfig. So you're like, how do I open the terminal with the keyboard? How do I, in the fastest way possible, right? How long should that take? How many delays should I have in order to wait for applications to open up? This is where testing comes in, and we're actually writing it, encoding it, and testing it. Then just optimizing it to make it as best as you can. And then once it is the best that it can be, you can use it and just deploy it and keep it ready for use. This is the most effective way to use the USB Rubber Ducky. Module 5 Ducky script, we're going to go through that in the next part. It's just the syntax of how to write a payload. Module 6 is payload principles. So it talks about how to effectively write how to properly write a payload. So you want it to be fast. You want it to be as quick as it can be, because every second counts, right? If someone left their laptop open and locked and they're in a coffee shop and they went up to get their order, you only have 5 to 10 seconds to do whatever you need to do, right? So you have to make sure that your payload is as quick as possible. Plus, if you're standing there for too long, people are going to notice. So speed is definitely a big part of it. Stages is something else that they covered. So there's two different types of payloads. There's inline and there's stages, right? Inline is just when the whole payload is just in one, payload. There's no external resources you may need. It's just one script that does the job. The other type is stages, or like a staged payload, and basically it works in stages or works in steps. Download a file off the internet would be a staged payload, right? Because the first stage is you have to get the payload from the internet onto the computer, and then the next stage would be to run it. The last type of principle is resources, and it's just a payload that uses external resources like a USB drive. So module 7 was talking about writing your first payload. We used the example of opening a notepad and then typing hello world on the notepad. So we first did the research, like what do we need to do? How can we open the notepad efficiently? And how many delays do we need? The most effective way to open anything on Windows pretty much is the run box. This is the payload that we made, right? So you wait 1 second, so that way the USB Rubber Ducky can be recognized as a keyboard for the computer. Then it will open up the run box, wait a millisecond, type in the executable file of Notepad, wait a second, and run it. Now that we wrote the payload, we need to encode it. So I typically use a Python encoder. The link is in the README of the GitHub page. But if you use the one that you downloaded from the Hack5 repository, you will get the Java one. There's another online encoder, and basically you can it's basically like an online IDE, right? You can type in your payloads here, and then you can encode the payload and put it on your Ducky. Now we got to the point where we're testing it, right? Let's see how effectively this payload works. And it works, but it's too long. And there's unnecessary string text because we already know our target is a Windows 10 computer. So we can still wait the 1 second, but we can now have a delay of 400 milliseconds. We only need to type in Notepad now because the run box will recognize Notepad as the command. So it's all about optimization, it's about knowing your target. The last module is module 8, which is obfuscation and optimization. So if you don't know what obfuscation is, it's basically just, like it says here, reducing the visibility of a payload. What we are doing in this example is hiding the command prompt. So we're not hiding command prompt, but making it harder to read. So basically this syntax right here, color FE, if you type that into a command prompt, it will make the color white, the background white and the text yellow, so it's super hard to read. And then this will just reduce the window size and make it really small and hard to read. So people who are watching or observing you won't be able to read what you're doing. It may still look sketchy, but they won't be able to read what you're doing. So optimization is, we covered it before, but it's to make it more efficient. We wanted to start an obfuscated CMD instead of starting a CMD and then running commands on the obfuscated CMD. So if we do it all in one step, it will take a lot quicker because we can unplug it and the step's already done. So as soon as we have the run box open, we can just use the cmd tag command or /c for command, and then just parse in both commands and run it. And this will obfuscate the command prompt for us in one command. So that's basically what they covered in this. So now let's go into the Ducky script itself. So the USB Rubber Ducky language or Ducky script is basically designed to emulate a keyboard, right? So all the commands of the language are based off of keys on the keyboard, and I'll kind of explain that in a second. So I expect you guys to have some sort of understanding of programming languages. Don't get me wrong, Ducky script is a very simple language. I learned it in like 5 minutes, but just so you guys know, if you'll have a better understanding if you've programmed before. But if you don't, I'll make it as easy to understand as I can. So first of all, the USB Rubber Ducky script is based on a language called BASIC. If you don't know the language, you don't need to. It's just there in case if you wanted to know. All the commands in Ducky script are capital, and the attributes for each command are lowercase. Delays are measured in milliseconds, so 1 second would be 1000 milliseconds. The first command is rem, which is short for remark, and basically it's just like a comment, right? You put it in the script, and basically the Ducky won't read it as code. It'll just read over it and ignore it. So if you want to label certain parts of your code or give yourself credit at the top, you can using the rem command. And just to clarify, so the rem right here is the command, and then this is the attribute. The default delay command basically creates a default delay in between each command. So the default delay with 1000, so 1000 milliseconds or 1 second, will create a 1 second delay between each command. The delay command just creates a single one-time use delay. So the string command, it just inputs text, right? So if I open up my notepad and how I'm typing right now, that's what the string command does. So if you type in string hello world, the Rubber Ducky will enter hello world. GUI or Windows key. The GUI command is just the Windows key, right? If I hit the Windows key, it opens up this little panel. And if you're on Windows, it will show up the start menu. So there's the menu command or the app command, and it's just the right click. So for example, if I right click and I wanted to select all, the A is underlined, so I can type in A and it will select everything. Shift, this is just the shift key. You can kind of see what I'm saying. Like all the commands are just named after the keyboard keys. Alt will hold down the Alt key. Control holds down the control key. Arrow keys, this basically just controls the arrow keys, and then these are all the other commands that the USB Rubber Ducky has. But again, this is on my GitHub if you guys need to see the syntax for yourself. So now let's actually write some payloads. So it is finally time we can write some payloads, because right now it's like 2 in the morning. It's been a little bit since I was last recording, but we finally read through the book, we read the notes, we learned the language, so we can finally write some payloads. So I'm gonna write 2 payloads today in this video, and then in future videos, probably like next week, I will be doing some cooler payloads like document exfiltration and stuff. But today's the Let's Learn video, so we're actually learning the basics, learning the fundamentals. So we should probably do like a hello world payload, and I may as well do a website payload as well, like some sort of web attack where it'll open up your web browser and open up some sort of website. So I feel like those 2 payloads would be pretty cool. So let's get into them, right? So we currently are in the USB Rubber Ducky Let's Learn directory. So we should make a new directory for our payloads. Then we should cd into our payloads. And in here, we're going to make our 2 other payload directories. So we'll have a hello world directory, and we'll have a web attack directory. Cool. So we'll start off with the hello world directory, and in here we will touch a payload.txt file. We can cd out of here, cd out of here as well, I guess. and Atom our current directory. So that way we can edit the txt files as well as looking at the Ducky script for reference in case if we need it. So there you go, USB Rubber Ducky, payloads, hello world, payload.txt. It is time for the research proportion of this. This should be fairly straight up because we're only opening up Notepad. So we know we need to hold the Windows key, hit R, and that was super quick to open up. So that's probably going to be relatively short. And to open up the run box or open up Notepad, we can literally type in Notepad, hit enter, and Notepad should open up. Let's actually start writing the payload. We're going to use the rem command with the attribute payload that opens Notepad and types hello world. So that's our goal. That's what we wanted to do. And now that I think about it, I do have a syntax highlighting for Ducky script. If you guys want to get the grammar highlighting or syntax highlighting for Ducky script, you can simply search up grammar tac Ducky, grammar Ducky script. This is the one I'm using. I'm sure there may be better ones, but this is one I use, so we're going to go with it. So let's give ourselves some credit with the command. So created by Cosmo. Cool. The first thing we want to do is give the computer some time to recognize that the USB Rubber Ducky is a keyboard, or to give it time to emulate itself as a keyboard, right? So allocates time for computer to recognize Ducky as a keyboard. By doing that, we just delay 1000 milliseconds or 1 second. Wait for the run box to open, so that should be about 100 milliseconds. And now we need to open Notepad. So how do we open Notepad now that we have the run box open? Well, we can simply just type in, using the string command, Notepad. And then we can hit the enter key. So now we can type hello world into the Notepad. So we have to wait some time for the Notepad to open. So we can delay about 200 milliseconds. And then from here, we can just use the string command and type in hello world. We finished the research step. We finished the writing step. So now it's time to encode. So how do we encode it? Well, I use the Python encoder that is linked in the README. So let's cd into the encoder directory. And if I Python the duck encoder, it has all the commands or how to encode a file. But I already know how to encode it, and I'm about to show you guys how to encode it. Python the duck encoder, and then we're going to use the tac I as an input. So the input file that we're going to be using is the payload.txt that we just made. So we're going to go to the payloads directory, the hello world directory, and the payload.txt. So this command basically will run Python using, or run the duck encoder.py. The tac I gets the input file of our payload.txt, and it will output it as an inject.bin file in the same directory. So we ran that, and now there's an inject.bin directory right here. You can't read it, but the USB Rubber Ducky can. When we put this file on the micro SD card into the USB Rubber Ducky, it will run a payload. All right guys, so if we open up my file explorer, or Kaja, whatever, here we have a micro SD card. All right, so what I'm going to do is copy the path to this micro SD card, then go into the terminal and have the inject.bin file just be sent straight to our micro SD card. So we have the Python duck encoder.py. It takes the input file of our payload that we just made and outputs it to the micro SD card right here as an inject.bin file. We hit enter, and if we go onto the micro SD card, there's the inject.bin file right there. Cool, so let's eject this, take it out of the computer, and plug it into the Ducky. And now we can plug this into our computer and see how that works. So we have the USB Rubber Ducky. It has the payload on it, the Hello World payload on it. So let's plug it in, and that is cool, dude. I don't know if you guys can see that. Let me make it bigger. Look at that, dude. I'll put my hands up so that way you guys don't think I'm cheating or whatever. So I'm gonna hit the button so that way it can rerun the payload. There you go. That is so cool, dude. That is so cool. So it just wrote hello world. That's awesome. All right, that was actually really cool. So I think using this similar concept, we can actually make another one. So let's try to make the web browser one. So let's cd out of here, cd into payloads. Actually, no, we don't have to. We're fine. So we can touch payloads, then the website one, and then payload.txt. Cool. So we made a payload.txt file. Now for websites, this should also be pretty straightforward, because with opening up the run box, we can literally type in www.example.com, have this open up, and it will open up the browser to example. Yeah, so that should be pretty straightforward. Rem, and we can say opens website. Cool. We can make the comment created by Cosmo, and cool. So the first thing we need to do is allocate time again. For allocate time for recognition, I'll just put, and here we can just delay 1000. Now we need to open the run box again. So open run box, and by doing this, we can just do a GUI-R, and we can delay for 100 milliseconds, which should be fine. Then we can open our website, right? So rem open website. Now what website should we open? We'll open my website. So we can do www.cosmodiumcs.com, and we can hit enter. Whoops. So that should be the entire payload. So we wait 1 second, hit the GUI-R to open the run box, wait 1 millisecond for the run box to open. We can type in our website name and then hit enter, and that will be it. So we can go ahead and get rid of this terminal page right here, get back onto this one, Python duck encoder.py. Our input file is going to be the payloads, and then the web attack payload.txt. Our output will be to that file /inject.bin. Awesome. And the last thing I'm going to do is have the file also be saved to the payloads folder that we have, just so that way you guys can access it on the GitHub as well. So payloads, web attack, inject.bin. Awesome. So if we minimize this, the inject.pin is right here in the web attack folder. so you guys can just play with it as soon as it comes out the box. And in here, it should also be right there. So we can eject this, unplug this, take it out, and put it in our USB Rubber Ducky. Cool, let's plug this in and see how it works. So we finished writing the website attack payload. Let's plug this in, see how well it works. It's plugged in, hands are up. Dude, that's so cool. That is so cool. I'm just waiting for the website to load because my Wi-Fi is bad, but there you go, Cosmodium CyberSecurity. If you haven't seen my website, feel free to check it out, www.cosmodiumcs.com. Dude, that's so cool. Oh man. So if I hit the button again, yeah, it just goes back. That is dope. That is awesome. Cool, so you could literally change the website name to any other website. That is awesome, dude. All right, guys, so that's gonna be it for the video. Thank you so much for watching. Hopefully you guys enjoyed this new series I've started. Hopefully it's going to be pretty entertaining. Let me know in the comments. But this, USB Rubber Ducky is just so cool. I'm thinking for the next video, I'm going to probably keep playing with this. We can do some document exfiltrations, probably what I'm thinking for the next video. But yeah, and I'm going to have more Let's Learns like this. I'll probably do some sort of video on like Nmap or some of the other Hack5 tools, Metasploit, even how to do like a proper like CTF and all that. So yeah, I think that's going to be a lot of fun. Anyways, hopefully you guys enjoyed this video. Make sure to leave a like, subscribe, do the whole YouTube algorithm thing, and I will see you guys in the next one. So stay happy, stay positive, and as always, happy hacking.